Why is winter so cold? I want to go swimming, but the water will be too cold.
Don't you know what a hot tub is?
You mean that tiny swimming pool outside? That's a hot tub?
Yes.
Oh, perfect. It'll be hot since it's a hot tub. Cannonball! It's cold. It's freezing. Oh my god!
You have to turn it on.
Hurry.
Hold up. Let me explain what is happening.
Hurry!
Okay, see how the water is steaming? That means it has reached its boiling point.
Boiling point. What does that mean?
So, water is room temp or regular from about 0 degrees Celsius to about 90 degrees Celsius. And 100 is, well, it's water's boiling point. The boiling point of a substance is the temperature at which the vapor pressure of a liquid equals the pressure surrounding the liquid, and the liquid changes into a vapor.
So, what you're saying is pretty much that water is hot?
Ugh, you're a lost cause. Just jump in the tub now. Look! Snow!
Look at the water. It's turning to ice.
Whoa!
It's reaching its freezing point.
What does that mean?
So, a freezing point is like the boiling water, but when water reaches a certain temperature as a physical change. Water's freezing point is 0 degrees Celsius.
That's so cool!
How are you doing that?
You don't know what surface tension is?
No.
Let me tell you. Surface tension is the property of the surface of a liquid that allows it to resist an external force due to the cohesive nature of its molecules. This can also be cohesion. Cohesion is pretty much when water is attracted to water. The stronger cohesion between the water molecules as opposed to the attraction of the water molecules to the air makes it more difficult to move an object through the surface than to move it when it is completely submerged.
Wow. Okay, so see that stream coming off the water? That's called heat of vaporization, or you can call it Lannett heat. It is an amount of energy that must be added to a liquid substance to transform a quantity of substance into gas. The heat of vaporization is a function of the pressure at which that transformation takes place. It is temperature dependent, though a constant heat of vaporization can be assumed for small temperature ranges and reduced temperature. Pretty much boiling point and Lannett heat go hand in hand.
No, why did the water move so fast and destroy it?
Ooh, I know, I can answer this question. This is something called viscosity. This is the measure of a resistance of a fluid to flow. Pressure and temperature are also considered when talking about viscosity of a liquid. If the viscosity doesn't change with pressure, we can describe it something as being a Newton fluid. However, if viscosity does change as stress or temperature changes, we describe it as something being a non-Newton fluid.
That's cool. Rylee, look, I want to show you something. See those icebergs?
Yeah? Why?
Did you notice they are floating on the water? That means ice is less dense than water. Density is the weight of a substance for a specific volume. The density of water is roughly 1 gram per millimeter, but this changes with the temperature or if there are other substances dissolved in it. The density of ice is about 90% that of water, but that can vary because ice can contain air too. That means that about 10% of an iceberg will be above the waterline.
Oh no! Ah!
Pause. Time for some input on what just happened. Let's slow it down a bit. See how Rylee is falling and there's lava underneath her? Yeah, she would have died if it wasn't for the water. Water is something called a universal solvent. It is capable of dissolving more substances than any other liquid. It is water's chemical composition and physical attributes that make it such an excellent solvent. Water molecules have a polar arrangement of oxygen and hydrogen atoms. One side, hydrogen, has a positive electrical charge, and the other side, oxygen, has a negative charge. Water can become so heavily attracted to a different compound, like salt, that it can disrupt the attractive forces that hold the sodium and chloride in the salt compound together, and thus dissolve it. Anyways, in Minecraft, water is being used as a universal solvent because it turns the lava into obsidian and makes a good landing spot so Rylee doesn't die. Again, so on with the example.
Oh, I'm all good. Thanks, water!
What are you doing?
Catching dinner, duh.
Oh.
Yeah, the fish we eat every night is from this river. Fish and other organisms can't live without water, and it helps the food cycle.
Oh. Okay, well, see you later.
Okay. Let me shine real quick, because it's my moment, and I gotta have a moment. See my very creepy skin? Yeah. Well, I'm oxygen. See those? Those are hydrogen atoms. As I move closer, I fuse with the hydrogen. Water has polar OH bonds, and the negative O atoms attract the positive H atoms in nearby molecules, not moleculars, leading to the unusual strong type of dipole-dipole force called a hydrogen bond. Since water has hydrogen bonds, it also has a dipole-included dipole and London dispersion forces. Okay, thanks. Spotlight's over. Back to the video.
So we can use water for many things. Farming. We can grow crops to either eat ourselves or feed to animals to later eat and breed. We can use it for potion brewing to protect ourselves from different things in this world. And we can collect it any times it rains or such. Well, that is the 11 properties of water. Thanks for tuning in.